Okay, here again I need to draw the directed graph for my relation R3. And here I only have two elements, which is going to make this a pretty quick problem. So we have 2 going to 3. So I have an arrow going from 2 to 3, and then an arrow going from 3 to 2. All right, and that's done. I do have to make sure that I include 0 and 1 in my graph because those are elements. So this altogether is the graph, not just this piece. So if you don't draw the whole thing, then your directed graph is incorrect. All right, so we want to determine whether the relation is reflexive. So that means that 0, 0, 1, 1, 2, 2, and 3, 3 would all be elements of R3, and none of them are. So I'm going to say no, and I can pick any one of them. I'll pick 0, 0. 0, 0 is not an element of R3. There you go. That's it. Could have said 1, 1. Whatever you like. Could have said 2, 2. All right, determine whether the relation is symmetric. Now, for it to be symmetric, if we have an ordered pair, such as 3, 2, that means that the reverse of that, switching the 3 and the 2, would also be an element. And we have that. So if 3 is paired with 2, and 2 is paired, or I should say 3 is paired with 2, and also 2 is paired with 3, and then there's no other elements there. So we're going to say yes. And how we show this, we have to do it by exhaustion, which is why they didn't throw in a whole lot, because you're going to see it's a little bit longer than you probably expect. So we have, what is it? Two, 3 is in R3, and 3, 2 is in R3. And then we can say just the reverse, actually, because what I'm going to do is I'm going to start with 3, 2 is an element of R3, and 2, 3 is an element of R3. And I'm really just doing this to emphasize the fact that it works both ways. So you really only need one of those. You don't need to write both of them out, but because they're saying the same thing, they're the same statement. Okay? But there you go. All right, so that one was a yes. Now we're looking for transitive. So what do we know? Well, we know that 2 goes to 3, and then we have 3 going to 2. So if this were transitive, that would mean that 2 should go to 2, because 2 goes to 3, which goes back to 2. So transitive says then 2 should go to 2. So that is not the case. We do not have 2, 2 in this relation. So I will say no. And then just say basically what I was saying a second ago. So 2, 3 and 3, 2 are elements of R3, but 2, 2 is not an element of R3. And that's how you do that problem.